64 light-years from the screen illuminating your face, a massive sphere of deep serene azure orbits a minor star in the constellation of Vulpecula. From a vast distance, its deep blue hue mimics the familiar oceans of Earth, suggesting calm waters and the quiet breathing of a habitable world. But this color is a physical deception. The blue does not come from the reflection of a tranquil sea. It is the visual signature of a planetary atmosphere saturated with silicate particles. On this world, known to our catalogues as HD 189733b, the ambient surface temperature rests at roughly 2000 degrees Fahrenheit. The atmosphere is not a pocket of breathable air, but a raging planetary-scale furnace of vaporized rock. Because the planet is locked in a permanent gravitational chokehold with its star, one hemisphere permanently faces an unrelenting stellar fire, while the other is trapped in a freezing, eternal darkness. This extreme temperature differential creates atmospheric currents of unimaginable violence. Winds howl across the Terminator line, the narrow twilight zone separating day and night, at speeds exceeding 5,000 miles per hour. That is roughly 7 times the speed of sound. At these raw velocities, the silicate particles suspended in the atmosphere do not simply float. They condense into solid shards of glass, which are then hurled sideways across the entire planet in a perpetual blinding hurricane. It is a ceaseless storm of shattered glass, moving fast enough to instantly reduce any carbon-based structure to microscopic dust. Moving deeper into the galactic arm, roughly 640 light-years away, the physics of survival become even more hostile. Here, a gas giant designated WASP-76b orbits so dangerously close to its parent star that its dayside temperature surpasses 4,300 degrees. At this thermal threshold, the basic molecular bonds of matter fail. Molecules separate into naked atoms. The heat is so intense that it vaporizes solid iron directly out of the planet's atmospheric core. This superheated iron gas is then carried by immense thermal winds to the cooler night side of the planet, where the temperature suddenly crashes. The iron gas condenses back into heavy, liquid droplets. On the dark side of this world, it rains molten iron from a pitch-black sky. These places are not the speculative anomalies of science fiction. They are physical certainties, confirmed by the cold, unforgiving data captured by our orbital observatories. They are immense, tangible locations with complex weather systems, crushing gravity, and deep atmospheres, operating right now with ruthless mechanical efficiency. For decades, the architectural blueprints of our own solar system served as the absolute baseline for human understanding. We assumed the cosmos operated on a standard logical template. Rocky worlds huddled close to the star, where the initial heat burned away the loose gas. Immense gas giants were pushed far out into the freezing depths, where they could safely accumulate their massive atmospheres over billions of years without being stripped apart by stellar winds. It was a neat, mathematically sound model of creation. The physics made sense. Then we built instruments capable of seeing the microscopic rhythmic dimming of distant starlight. We looked outward, expecting to find echoes of our own quiet neighborhood. Instead, we uncovered a violent, chaotic reality that completely shattered our fundamental models of planetary formation. We found colossal gas giants, worlds thousands of times more massive than Earth, sitting mere fractions of an astronomical unit from their host stars. They are so close that their outer atmospheres are literally boiling off into the vacuum of space, creating massive trails of planetary debris stretching for millions of miles. According to the strict laws of thermodynamics and gravity, these massive worlds cannot form that close to a stellar furnace. The raw material simply could not survive long enough to coalesce. The immense radiation should have obliterated their genesis before a core could even take shape. And yet there they are, massive, burning and utterly defying the very equations we use to map the universe. They are entirely in the wrong place. By all known logic of astrophysics, they should not exist. Something entirely unseen, something terrifying and immensely powerful, must have happened in the dark to drag these colossal giants from the freezing outer edges of their systems directly into the fire. To understand the brutal architecture of these systems, we must discard the comforting illusion of stability. We instinctively view a solar system as a finished clockwork mechanism, an orderly arrangement of spheres moving in perpetual, unchanging harmony. But the cosmos does not build in peace. Planetary formation is an era of immense chaotic violence, and the presence of colossal gas giants burning right next to their stars is the ultimate proof of this violent genesis. Astrophysicists call this process orbital migration, a sterile term that masks a terrifying physical reality. When a star is born, it is surrounded by a protoplanetary disk, a swirling massive hurricane of primordial gas, microscopic dust and ice stretching for billions of miles. Deep within the freezing outer bands of this disk, where temperatures are low enough for volatile gases to condense, the seeds of giants are sown. A solid core of rock and ice coalesces, pulling in surrounding matter with increasing gravitational authority. Once this core reaches a critical mass, roughly 10 times the mass of Earth, a runaway accretion process begins. The planet rapidly vacuums up the surrounding hydrogen and helium, swelling into a monstrous gas giant. In our system, Jupiter and Saturn went through this exact process and then largely settled into their distant, cold orbits. But in the systems containing the burning giants we now observe, the environment was fundamentally different and far more lethal. In these systems, the protoplanetary disk was likely much thicker, denser, and far more viscous. As the newly born gas giant plowed through this dense cosmic soup, it encountered relentless aerodynamic drag. The immense friction of the gas and dust acted as a brake against the planet's orbital momentum. In physics, when orbital energy is lost, gravity wins. The giant began to fall. It did not drop straight down, but spiraled inward, embarking on a millions of years-long death march toward the nuclear furnace of its host star. This inward migration is a planetary-scale disaster. As a mass thousands of times heavier than Earth plows inward, its immense gravitational field acts like a chaotic wrecking ball swinging through a glass house. Any nascent, rocky planets forming in the inner system, worlds that could have eventually harbored oceans or perhaps life, are violently disrupted. The migrating giant's gravity catches them in a relentless tidal grip. Some of these terrestrial worlds are accelerated to impossible velocities and entirely ejected from the solar system, banished into the frozen, lightless void of interstellar space to wander as rogue planets for eternity. Others are not so lucky. Their orbits are destabilized, decaying rapidly until they are swallowed whole by the star. Their entire geological history annihilated in a brief flash of stellar combustion. The gas giant continues its inward plunge, leaving a wake of gravitational devastation, only halting its death spiral when the inner edge of the gas disk dissipates, or when the star's tidal forces become strong enough to lock it into a permanent, agonizingly close orbit. This is the dark, unseen history of the universe. Entire architectures of potential life routinely bulldozed into oblivion by wandering giants. The realization that the universe operates as a hostile, chaotic engine did not come from philosophical deduction. It was dragged into the light by the most ambitious and mechanically precise act of observation in human history. To find these worlds, we did not look for their faint reflected light. A planet is millions of times dimmer than its star. Trying to see one directly is like trying to spot a firefly crawling across the lens of a lighthouse from 3,000 miles away. Instead, we looked for the shadows. In the spring of 2009, we launched a machine designed to do nothing but stare into the abyss. The Kepler Space Telescope was placed into an Earth-trailing heliocentric orbit, free from the optical distortion of our atmosphere and the blinding cycles of day and night. It was equipped with a massive array of specially designed charge-coupled devices, a 95-megapixel camera held in a cryogenic vacuum. But Kepler was not designed to take beautiful pictures of galaxies. It was a cold, calculating photometer. It was pointed at a single, unchanging patch of the Milky Way, a dense field of stars spanning the constellations of Cygnus and Lyra. And then, it simply watched. It monitored the exact brightness of over 150,000 individual stars, simultaneously, without blinking, for years. The engineering required for this task bordered on the absurd. Kepler was looking for transits, the microscopic dip in starlight that occurs when a planet passes exactly between the face of its star and the telescope's aperture. When an Earth-sized planet transits a sun-like star, it blocks roughly 1/100% of the star's light. To detect this, Kepler's sensors had to be sensitive enough to measure a change in illumination equivalent to a single flea walking across a car headlight. Furthermore, the alignment had to be mathematically perfect. The orbital plane of the distant system had to be precisely edge-on to our line of sight. If the planet orbited even a fraction of a degree too high or too low, it would cast no shadow toward Earth, and we would see nothing. Statistically, for every one transiting system Kepler found, there were hundreds more angled away in the dark, entirely invisible to us. The data beamed back from the silent void of Cygnus systematically dismantled our preconceptions of planetary physics. The first wave of discoveries brought the gas giants, the immense anomalies that shattered our models. But as the telescope stared longer, measuring the microscopic dimming over months and years, the shadows grew smaller, and the implications grew infinitely more terrifying. We began to find rocky worlds, planets with solid surfaces, mountains, and crusts. But the universe did not offer us reflections of Earth. It offered us extremes that defy biological comprehension. Consider the mechanics of the system's orbiting red dwarf stars. These are the most common stars in the galaxy, outnumbering our Sun by a massive margin. They are small, dim, and burn their hydrogen fuel at an incredibly slow rate, granting them lifespans of trillions of years. Because they are so cold, their habitable zone, the narrow orbital band where liquid water could theoretically exist on a planet's surface, is drawn violently inward. A planet must hug the star at an incredibly close distance to stay warm. But gravity is a merciless force, and proximity exacts a physical toll. When a planet orbits that close to a massive gravitational body, the immense tidal forces begin to warp its physical structure. The gravitational pull on the side of the planet facing the star is significantly stronger than on the far side. This differential creates tidal friction within the planet's mantle and crust, acting as a massive geological brake. Over millions of years, this friction continuously slows the planet's rotation. Eventually, the rotation is entirely killed. The planet's orbital period synchronizes perfectly with its rotational period, locking it in a permanent, inescapable configuration known as tidal locking. This creates a world permanently fractured in two. One hemisphere faces the star in an eternal, unending day, baked by relentless radiation, where there are no seasons, no twilight, and no relief. The other hemisphere is cast into eternal, freezing darkness, pointing endlessly out into the frozen void of deep space. Between these two extremes lies the terminator, a razor-thin band of permanent twilight, where the atmosphere is caught in a violent, never-ending war of thermal circulation, trying and failing to balance the impossible temperature gradient. If these worlds possess oceans, the water on the day side boils into a thick, suffocating steam atmosphere, while the oceans on the night side are locked in a permanent, miles-thick shell of black ice. Yet, the thermal nightmare of tidal locking is only the beginning of the hostility. Red dwarfs, despite their dimness, are incredibly violent magnetic engines. Because they are fully convective, the plasma inside them churns from the core straight to the surface, twisting their magnetic fields into chaotic, unstable knots. When these magnetic lines inevitably snap and reconnect, they unleash titanic bursts of energy. These stellar flares and the accompanying coronal mass ejections dwarf anything our Sun produces. Because the planets are parked so close to the star, they take the full, unfiltered brunt of these apocalyptic storms. When a massive flare strikes a tidally locked rocky planet, it is an act of planetary sterilization. The high-energy X-ray and ultraviolet radiation instantly shatters the molecular bonds of any atmospheric gases. The extreme solar wind, a hurricane of charged particles moving at millions of miles per hour, physically impacts the planet's upper atmosphere, ionizing the air and blowing it directly out into the vacuum of space. Over the course of 1 billion years, a red dwarf can violently strip a rocky planet of its entire atmosphere, boiling away its oceans and leaving nothing but a barren, irradiated core of scorched rock, silently locked in a staring contest with the very star that murdered it. These are not rare anomalies. The mathematics of the Kepler data extrapolate to a chilling conclusion. There are hundreds of billions of planets in our galaxy alone. The architecture of the cosmos suggests that extreme, hostile environments are not the exception. They are the absolute rule. The silent, dead worlds, stripped by stellar winds, the colossal gas giants burning in the corona of their stars, the rogue planets drifting through the freezing black. This is the true face of the universe. It is a vast, indifferent machine operating on a scale and violence that renders human existence a statistical impossibility. If you seek the truth in the dark and wish to stare directly into the unforgiving machinery of the cosmos, subscribe and join us on this journey. To comprehend the sheer scale of the anomaly we are observing, we must understand the mechanics of the instruments mapping the dark. We are not pointing optical magnifying glasses into the void. We are not capturing photographs of these distant, hostile environments. The physical distance between our solar system and these exoplanets renders any traditional concept of photography utterly obsolete. If an Earth-sized planet orbits a star 100 light-years away, trying to resolve its surface is mathematically equivalent to standing in New York City and trying to see the structural lattice of a single snowflake falling in Tokyo, while a high-intensity searchlight is pointed directly into your eyes. The host star is billions of times brighter than the planet. The glare is absolute. Instead of looking for the planet itself, we decode the faint, invisible messages hidden within the starlight. This is the science of transit spectroscopy, and it is a mechanical process of terrifying precision. When a planet passes in front of its host star, a microscopic fraction of the star's light physically passes through the extreme upper layers of the exoplanet's atmosphere before continuing its long journey across the interstellar vacuum. As these photons pass through the alien air, the specific gases suspended in that atmosphere act as a selective filter. Every chemical element in the universe absorbs light at a highly specific, mathematically fixed wavelength. When this filtered starlight finally strikes the beryllium mirrors of our orbital observatories, hundreds or thousands of years later, we feed it through a spectrograph. We physically shatter the light into its constituent wavelengths, spreading it out into a vast, detailed spectrum. We then look for the missing pieces. We look for the dark bands in the spectrum, the exact wavelengths that were swallowed by the gases of the alien world. It is the equivalent of reading an incredibly complex barcode in pitch darkness. Through this method, we do not just know that a planet exists, we know the molecular weight of its air. We know if it is choking on carbon monoxide, if it is raining liquid glass, or if its atmosphere is boiling away into the void. We touch the texture of unreachable worlds through the forensic dissection of broken light. And what this shattered light reveals is an architecture of reality so extreme, it borders on the grotesque. Deep in the constellation of Draco, roughly 750 light-years from Earth, sits a gas giant catalogued as TRES 2b. By all structural accounts, it is a Jupiter-sized planet orbiting a yellow dwarf star. But when we measure the optical mechanics of this world, the data breaks our standard models of planetary physics. In astrophysics, the reflectivity of a celestial body is measured by its albedo. An object with an albedo of 1 reflects all light, like a perfect mirror. Earth has an albedo of roughly 0.3, reflecting about 30% of the sun's light, primarily due to our white clouds and vast oceans. Enceladus, the frozen moon of Saturn, has an albedo of nearly 0.99. It is a blindingly bright sphere of pure ice. TARIES 2b has an albedo of less than 0.01. It reflects less than 1% of the starlight that strikes its upper atmosphere. It is darker than black acrylic paint. It is darker than pure, unrefined coal. It is, mathematically, the darkest known planet in the universe. The physics required to swallow that much light are difficult to fathom. This is not a solid sphere of dark rock. It is a massive, swollen globe of gas operating at nearly 1800 degrees Fahrenheit. Our atmospheric models suggest that this light-devouring void is caused by an atmosphere entirely devoid of reflective ammonia clouds, the clouds that give our Jupiter its bright, striped appearance. Instead, the extreme heat of TRES 2b prohibits the formation of anything reflective. The atmosphere is likely saturated with light-absorbing chemicals like vaporized sodium, potassium, or gaseous titanium oxide. These elements act as an infinite microscopic sponge, capturing the incoming photons and instantly converting their energy into heat. But Tauri 2b is not entirely invisible, because it is trapped in such a tight, agonizingly close orbit to its star. The immense thermal energy it absorbs must go somewhere. The planet is so hot that it emits its own faint, deep crimson glow. It is not reflecting light, it is radiating raw heat. If you were to witness it up close, it would not look like a planet. It would look like a colossal silent sphere of dying embers suspended in a total void. A massive pitch-black furnace burning quietly in the dark. Moving away from the gas giants, the solid worlds present a different, far more crushing form of hostility. 40 light-years away in the constellation of Cancer, a rocky world designated 55 Cancri E orbits its star at a distance so close that its year lasts only 18 hours. It is classified as a super-Earth, possessing twice the radius of our planet and roughly 8 times the mass. But the true terror of 55 Cancri E lies in its chemical composition and the immense, unyielding pressure of its gravity. In the protoplanetary disk where our Earth formed, oxygen was far more abundant than carbon. This oxygen bonded with silicon to form the silicates that make up our mantle, our crust, our rocks, and our sand. The carbon was left as a trace element, the biological scaffolding for life, but geologically insignificant. But the universe is not uniform. In the disk that birthed 55 Cancri E, the ratio was inverted. Carbon was the dominant element. This world was forged not from silicate rock, but from carbon compounds. When you combine a carbon-rich planetary composition with 8 times the mass of the Earth, the laws of chemistry are subjected to the brutal enforcement of gravity. Deep beneath the surface of this world, the atmospheric pressure and geological weight reach millions of times the atmospheric pressure at Earth's sea level. In normal conditions, pure carbon arranges its atoms in loose, flat, hexagonal sheets. We know this material as graphite. It is dark, soft, and brittle, but when carbon is subjected to the hyperpressure inside 55 Cancri E, the loose sheets are violently crushed together. The space between the atoms is squeezed out of existence. The carbon atoms are forced to bond in a rigid, three-dimensional tetrahedral lattice. The graphite physically phase shifts into diamond, but this is not a crystalline jewel floating in space. It is a massive, suffocating geological layer of hyperdense diamond, thousands of miles thick, acting as the structural mantle of the planet. And because the planet is tidally locked and roasts at a surface temperature of over 4,000 degrees, this diamond layer is trapped beneath an ocean of molten, liquid carbon. It is a world where the continents are forged of black diamond, submerged in boiling graphite, locked in an endless, searing daytime. It demonstrates that the universe can take the rarest, most prized chemical structures of human civilization and mass-produce them on a planetary scale, rendering them completely inaccessible in an environment of absolute, incinerating violence. Yet heat and carbon are not the only ways the cosmos breaks our intuition. 33 light-years away, orbiting a dim red dwarf in the constellation of Leo, is Gliese 436b. This planet is roughly the mass of Neptune, and it sits incredibly close to its host star, enduring a surface temperature of roughly 800 degrees Fahrenheit. Common sense, built upon the physics of our own temperate world, dictates that at this temperature, any water present would instantly boil into vapor. An 800-degree planet should be a scorching sphere of dry rock or superheated steam. But the cosmos does not respect common sense. It respects only mass and pressure. Gliese 436b possesses an immense gravitational field, and this gravity creates a physical paradox. Deep within the planet, the pressure reaches a point where the fundamental behavior of the water molecule is overthrown. When water freezes on Earth, the molecules arrange themselves into a hexagonal crystalline lattice, a structure known as ice-eye. This lattice takes up more physical volume than liquid water, which is why ice expands and floats. But under the crushing gravitational weight of Gliese 436b, water cannot expand. The extreme pressure forces the hydrogen and oxygen atoms into highly compacted, incredibly dense cubic structures. These exotic phases of matter are known to physicists as Ice 7th or Ice X. In these hyperdense states, the water is entirely solid, but it is not cold. The extreme pressure acts like an invisible planetary-scale vice, locking the atoms in place so tightly that they cannot vibrate into a liquid or gaseous state, despite the overwhelming 800-degree heat trying to tear them apart. The planet is a massive ocean of burning solid ice. It is an environment where the heat is intense enough to melt lead, yet the water remains a rigid, impenetrable solid simply because gravity refuses to let the molecules move. The deeper we push our instruments, the more we witness the physical breakdown of planetary bodies in real time. We are not just observing stable, static systems, we are watching planetary executions. Look closely at the data from Kepler 1520b, a small rocky world roughly 1,500 light-years away. When this planet transits its star, the shadow it casts on our sensors is wrong. A normal solid planet blocks the light sharply, creating a clean, symmetrical dip in the star's brightness. Kepler 1520b produces an asymmetric light curve. The shadow drops sharply as the planet enters the transit, but it trails off slowly, lingering in the data long after the planet has passed. This trailing shadow is not an atmospheric anomaly. It is the physical debris of a dying world. Kepler 1520b orbits so agonizingly close to its star that its surface temperature exceeds 3,600 degrees. At this thermal threshold, the rocky crust of the planet does not just melt, it boils. The silicates and metals that make up the planet's surface literally evaporate, turning into a dense cloud of vaporized rock. Because the planet is relatively small, its gravity is too weak to hold onto this massive, superheated atmosphere. The intense radiation and stellar wind from the host star catch the vaporized rock, cooling it instantly back into microscopic solid dust particles. This process creates a massive, trailing tail of planetary debris, highly similar to the tail of a comet, but made entirely of pulverized rock and stretching for millions of miles into space. The asymmetric shadow we see is the tail of the planet blocking the starlight. We are watching Kepler 1520b bleed its mass into the void. It is disintegrating before our eyes, caught in a fatal, inescapable orbit, destined to be entirely eroded into a stream of dust, leaving nothing behind but an invisible gravitational memory. But even a disintegrating planet orbiting a furious star implies a standard solar system model. The ultimate proof of the universe's indifference lies in environments where planets should not exist at all. In the constellation of Virgo, 2,300 light-years away lies the Drauga system, officially designated PSR B1257+12. The central body of this system is not a star, it is a corpse. Millions of years ago, a massive, brilliant star, perhaps 10 times the mass of our Sun, exhausted its nuclear fuel. Without the outward pressure of nuclear fusion to counteract its own immense gravity, the star's core collapsed inward at a fraction of the speed of light. The outer layers were blown away in a supernova, an explosion of such cataclysmic violence that it outshone the entire galaxy, instantly incinerating and vaporizing any planets that had the misfortune of orbiting it. The collapsed core remained. The mass of an entire sun was crushed down into a sphere roughly 12 miles in diameter. The protons and electrons in this core were squeezed together so violently that they fused into pure neutrons. This is a pulsar, a rapidly rotating neutron star. It spins hundreds of times per second, emitting twin beams of lethal, highly concentrated electromagnetic radiation from its magnetic poles. The magnetic field surrounding it is 1 trillion times stronger than Earth's. It is the most violent, hostile, and radioactive environment in the known universe, a place of absolute physical extremity. And yet, sitting directly in the radiation zone of this dead star, we found them. 3 distinct planetary bodies, Poltergeist, Phobetor, and Drauga. They are the first exoplanets humanity ever discovered, and their existence defies all conventional logic. They could not have survived the supernova. The physics of the blast wave guaranteed total planetary annihilation. Therefore, they must have formed after the star died. In the chaotic aftermath of the explosion, the shattered remnants of the star, the heavy metals and radioactive ash that failed to escape the immense gravity of the pulsar, formed a secondary protoplanetary disk. Out of this lethal glowing debris, matter began to coalesce once again. Gravity, blind and relentless, forced the cosmic shrapnel to bind together, building new worlds out of the wreckage of the old. These are zombie planets. They orbit a flashing, erratic atomic clock of a dead star, bathed constantly in a storm of hard X-rays and high-energy particles. The radiation environment is so severe that it would strip away human DNA, atom by atom, in a fraction of a second. The sky above them is not filled with the warm, steady light of a yellow sun, but the strobing, lethal flashes of a neutron star spinning wildly in the dark. They are silent, irradiated monuments proving that the mechanics of the universe will build worlds anywhere out of anything, no matter how toxic or violent the environment. The scale of this hostility forces a severe recalculation of our place within the dark. We are looking at a gallery of physical extremes, where the basic laws of chemistry, gravity, and thermodynamics are pushed to their breaking points, twisting matter into configurations that challenge the very limits of our mathematical comprehension. But observing these extremes is one thing. Attempting to reconcile them with the foundational laws of physics, attempting to understand how long these brutal mechanisms can endure before the math itself breaks down, reveals a much deeper, more fundamental problem. The fundamental problem with discovering environments of such extreme physical violence is that observation eventually outpaces comprehension. We possess the engineering capacity to detect the shadow of a disintegrating world, but when we attempt to feed the physical parameters of that world into our foundational equations of state, the mathematics begin to fracture. We have reached a frontier where the data we collect directly contradicts the established laws of physics we use to understand reality. We are hitting the theoretical barrier, a point where human science is forcefully reminded of its own architectural limitations. Consider the interior of a super-Earth like 55 Cancri E, the world buried under an ocean of liquid carbon and a mantle of hyper-compressed diamond. To understand how a planet like this generates its magnetic field, or how its tectonic plates might operate under such crushing gravity, geophysicists must calculate the behavior of matter at the exact center of the world. In physics, we do this using an equation of state, a mathematical model that describes the relationship between pressure, volume, and temperature for a given substance. For the Earth, these equations work perfectly. We can simulate the behavior of iron and nickel in our core with extreme precision. But when we apply these same equations to the crushing depths of a super-Earth, the mathematics collapse into absurdity. At pressures exceeding tens of millions of atmospheres, the space between atoms is obliterated. The electrons orbiting the atomic nuclei are stripped away and forced into a chaotic, hyper-dense fluid state known as a degenerate electron gas. At this exact threshold, the two undisputed pillars of modern physics, general relativity and quantum mechanics, are forced into a violent, irreconcilable collision. General relativity dictates how the immense, macroscopic mass of the planet bends space-time and generates gravity. Quantum mechanics dictates how the microscopic subatomic particles resist being crushed into a singularity through a phenomenon known as Pauli exclusion principle. In our current framework of physics, these two theories refuse to speak the same language. When we try to mathematically bridge the gap between the crushing macroscopic gravity and the microscopic quantum resistance inside these alien cores, our equations return infinities. The math simply breaks. It yields impossible numbers, theoretical paradoxes that suggest our fundamental understanding of how matter behaves under extreme stress is entirely incomplete. We literally do not possess the mathematical vocabulary to describe what is happening in the dark, silent center of these massive worlds. It is a blind spot in human knowledge, an impassable wall of ignorance forged by the limits of our own theories. This theoretical barrier extends far beyond the cores of solid planets. It plagues our understanding of the colossal burning gas giants as well. The very existence of hot Jupiters, those massive gas giants orbiting mere millions of miles from their stars, creates an immense thermodynamic paradox. According to the laws of fluid dynamics and heat transfer, an atmosphere subjected to 4,000 degrees of stellar radiation should not remain stable. The kinetic energy of the gas molecules should be so unimaginably high that the thermal velocity exceeds the planet's escape velocity. The hydrogen and helium should simply boil off into the vacuum of space, stripping the planet down to its bare, rocky core in a matter of a few million years. Yet these burning giants endure. They have orbited their stars for billions of years, retaining their massive atmospheres in direct defiance of thermodynamic evaporation models. To explain this survival, astrophysicists hypothesize the existence of colossal, planetary-scale magnetic fields, hundreds of times stronger than Jupiter's, acting as an invisible shield against the stellar wind. But generating a magnetic field of that magnitude requires a rapidly rotating core of liquid metallic hydrogen. And here, the paradox deepens. Because these hot Jupiters are parked so close to their stars, they are tidally locked. Their rotation has been violently braked by gravity. They spin incredibly slowly, taking days or weeks to complete a single rotation. A slow rotation cannot generate the dynamo effect required to build a massive magnetic shield. The physics demand a shield that the mechanics of the system cannot provide. The equations of thermodynamics state the atmosphere should be gone. The equations of orbital mechanics state the magnetic dynamo should be dead. And yet the planet sits there in the telescope data, massive, intact, and mocking the equations we use to define reality. It forces us to confront the chilling possibility that there are entire branches of physics, unknown mechanisms of energy transfer and fluid dynamics, operating in the cosmos that we have not yet discovered, and perhaps lack the cognitive architecture to ever fully understand. Even when we step away from the internal structure of these worlds and attempt to model their macroscopic movements, we hit an insurmountable mathematical wall. The systems we observe, featuring migrating giants plowing through planetary debris, are governed by gravitational interactions between multiple massive bodies. In the late 17th century, Isaac Newton gave us the gravitational equations to perfectly predict the motion of two bodies interacting in a vacuum, a star and a single planet. It is a neat, solvable mathematical problem. The future of a two-body system can be predicted with absolute certainty until the end of time. But the moment you introduce a third gravitational body into the equation, a second planet, a migrating giant, or a passing star, the mathematics descend into an unbreakable regime of deterministic chaos. This is known as the n-body problem, and it is one of the most brutal, unforgiving limitations in all of astrophysics. There is no generalized, closed-form mathematical solution for the movement of three or more bodies interacting under their own gravity. The gravitational tugs are reciprocal and continuous. Every movement alters the gravitational field, which in turn alters the next movement in an infinite, unresolvable feedback loop. To predict the orbits in these extreme exoplanetary systems, we are forced to rely on numerical integration. We use supercomputers to calculate the gravitational forces for a single second, move the simulated planets a microscopic fraction of an inch, and then recalculate the entire system all over again. We do this billions of times to simulate a single year. But the mathematics reveal a merciless truth. In an n-body system, microscopic variations in the initial data compound exponentially over time. A difference of a single millimeter in the starting position of a simulated gas giant will, over the course of 1,000,000 years, result in a completely different solar system. In one simulation, the giant settles into a stable orbit. In another, identical simulation with a microscopic mathematical rounding error, the giant ejects all other planets into the void and crashes into the star. Because our observational data always contains a tiny margin of error, our instruments are never infinitely precise. Therefore, predicting the deep future or mapping the deep past of these chaotic systems is mathematically impossible. We cannot know how these burning giants arrived at their current locations. We cannot know how many terrestrial worlds they murdered along the way. And we cannot know if their current agonizing orbits will remain stable for another 1,000,000,000 years, or if they will suddenly decay tomorrow. The universe operates on a foundational level of unpredictability. It is a machine that violently erases its own history and perfectly obscures its own future. And this obscurity is compounded by the most unbreakable barrier of all, the speed of light. The systems we are desperately trying to understand are hundreds or thousands of light years away. The photons carrying the transit data across the void are ancient. When we observe the disintegrating tail of Kepler 1520b, we are not watching a present-day event. We are watching a ghost. The data we collect is a fossilized recording of a planetary execution that occurred over a millennium ago. This creates a terrifying information horizon. The present state of the universe is permanently locked away from us. By the time the light from a distant, violent orbital collision reaches our mirrors, the civilization that might have inhabited a neighboring world has been dead for 1,000,000 years. We are trapped in a narrow, delayed bubble of perception, trying to deduce the fundamental laws of a chaotic universe by watching a severely degraded, heavily delayed broadcast of its ancient past. We build massive multi-billion-dollar cryogenic telescopes, park them in the freezing vacuum of the Lagrange points, and capture the faintest whispers of infrared radiation, only to realize that the universe has deliberately engineered a reality where the closer we look, the more the fundamental truth retreats behind a wall of theoretical paradox and infinite mathematical chaos. When we internalize the sheer scale of this temporal delay, the fundamental nature of our reality begins to unravel. We look up at the night sky and instinctively feel we are standing in a shared synchronous universe, participating in a collective present moment. But the data from our observatories dictates a much colder truth. There is no cosmic present. The speed of light is not just a physical speed limit, it is a mechanism of total temporal isolation. Every star you see, every transit we measure, is a transmission from a different epoch. We are trapped inside a perceptual quarantine. If a civilization on one of those distant worlds were to look back at our solar system at this exact moment, they would not see our cities, our satellites, or our oceans. Depending on their distance, they might see the Earth as a molten ball of magma recovering from the impact that formed the Moon, or a frozen snowball caught in a global ice age, or an empty patch of space where our sun has not yet ignited. We are mutually invisible, separated not just by millions of miles, but by an impenetrable wall of time. The universe we map is a grand illusion, a composite photograph constructed from millions of different dead eras, stitched together by the agonizingly slow crawl of photons across the void. This physical isolation carries a profound and terrifying consequence for the existence of life. For decades, the human search for understanding our place in the dark has been driven by a quiet, optimistic assumption that the universe is a vast, fertile landscape waiting to be seeded with consciousness. We calculated the billions of stars and assumed billions of chances for biology to take hold. But the architectures of the exoplanetary systems we have uncovered violently dismantle this optimism. The chaotic orbital migrations, the sterilizing radiation fields of the pulsars, the planetary-scale incinerators of the hot Jupiters, the atmosphere-stripping winds of the red dwarfs. These are not rare, unfortunate accidents. They are the standard operating procedure of a universe driven blindly by gravity and thermodynamics. Biological life is an incredibly fragile chemical configuration. It requires an unbroken, miraculous chain of environmental stability stretching across billions of years. It requires a star that does not randomly double its radiation output or lash out with lethal flares. It requires an orbit that remains perfectly circular, never drifting too close to the fire or too far into the freezing dark. It requires massive outer planets to act as gravitational shields, absorbing the impacts of wandering asteroids, without those same massive planets suddenly migrating inward and throwing the entire inner system into a chaotic death spiral. The universe does not owe us stability. In fact, the mechanics of planetary formation actively conspire against it. The quiet, orderly clockwork of our own solar system is not the blueprint of the cosmos. It is a mathematical anomaly. We are living in a temporary, highly improbable pocket of silence within a deafening, grinding machine. The realization is absolute. The universe is not a nursery. It is a slaughterhouse for nascent worlds, blindly crushing the potential for biology before it can even begin to organize. If we project the mathematics of these hostile environments forward into the deep time of the cosmos, the ultimate consequence of this machinery becomes devastatingly clear. We are currently living in the stelliferous era, the brief, chaotic window in the timeline of the universe where stars ignite, burn, and explode, driving the complex chemical reactions that allow planets and biology to exist. But this era is mathematically finite. The relentless arrow of entropy dictates that every system, no matter how violent or energetic, must eventually wind down into absolute equilibrium. Take the colossal burning gas giants, the worlds locked in fatal embraces with their host stars. Their survival is only a temporary defiance of gravity. The orbital mechanics that halted their inward death spirals are slowly, inevitably degrading. Tidal forces are constantly sapping their orbital energy, bleeding it out as internal friction and heat. Millimeter by millimeter, century by century, their orbits decay. Eventually, perhaps in 10 million years, perhaps in a billion, they will cross the final threshold. The gravitational gradient of the star will become stronger than the chemical bonds holding the planet together. The star will physically tear the giant apart, unspooling its mass into a colossal spiraling ring of incandescent gas before pulling it down into the stellar furnace, erasing billions of years of planetary history in a matter of hours. The skies of those systems will eventually be empty. The red dwarfs, those violent flaring engines that currently strip their rocky planets to the bone, will outlive almost everything else in the galaxy. Their fuel consumption is so incredibly efficient that they will continue to burn for trillions of years, long after our own sun has expanded, incinerated the Earth, and died as a fading white dwarf. But even the red dwarfs are not infinite. They will eventually exhaust their supply of hydrogen. Because they lack the mass to ignite heavier elements, they will not explode in brilliant supernovas. They will simply stop. They will slowly cool, shrinking into dark, hyperdense spheres of degenerate matter known as black dwarfs. And orbiting these invisible dead stars will be the frozen, irradiated corpses of their tidally locked planets. Worlds that once boiled under eternal daylight will plunge into eternal night. Any remaining atmosphere will freeze solid and fall to the surface as dry snow. They will become spheres encased in miles of black ice, their cores solid and cold, orbiting in absolute, silent darkness. They will continue this silent waltz around their dead stars for a time frame that entirely breaks human comprehension, long after the last photon of starlight in the universe has faded away. Then there is the hidden consequence of the rogue planets, the countless worlds violently ejected from their solar systems during the chaotic migrations of the early universe. Trillions of massive spheres, ranging from scarred rocky terrestrials to swollen gas giants, drifting untethered through the freezing interstellar void. Without a host star to anchor them, they are subjected to the absolute zero of deep space. Any oceans they might have possessed froze solid billions of years ago. Any internal heat generated by their radioactive cores has slowly, relentlessly radiated away into the vacuum. They are perfectly preserved, sterile monuments of dead potential, doomed to wander the infinite dark forever. They will never see another sunrise. They will never experience a season. They will never feel the warmth of a star. They will simply drift, invisible and entirely silent, until the accelerating expansion of the universe pulls the fabric of space so far apart that they are entirely alone, isolated in an empty sector of reality where even the light of distant galaxies can no longer reach them. This is the profound hidden consequence of looking at the most disturbing exoplanets in our catalogues. They are not merely distant scientific curiosities or abstract mathematical data points. They are physical mirrors reflecting the absolute, indifferent mechanics of our own reality. They force us to violently discard the arrogant biological assumption that the universe was engineered to accommodate us. They prove, through the cold, hard data of transit spectroscopy and orbital mechanics, that the fundamental forces governing the cosmos do not care about the delicate chemical reactions we call life. The incinerated rocks orbiting the red dwarfs, the disintegrating tails of the dying worlds, the zombie planets bathed in the lethal radiation of a dead pulsar, the light-devouring gas giants burning in the dark. These are the natural, inevitable products of gravity, radiation, and time. Our existence on this quiet blue sphere is a temporary, highly localized defiance of those natural products. We are balancing precariously on a razor's edge of statistical probability, surrounded on all sides by a void that is actively, mechanically hostile to complex structure. When we map the extreme architecture of the galaxy, we are ultimately mapping our own profound fragility. The exact same fundamental forces that evaporate a planet in the constellation of Cygnus or crush carbon into diamond in the constellation of Cancer are operating right here in our own neighborhood. We are not insulated from the physics of the void. The sun that provides the energy for our biosphere is slowly, inexorably increasing its luminosity. In roughly 1 billion years, long before the sun even begins its final expansion into a red giant, that gradual increase in solar radiation will push the Earth past a fatal thermal tipping point. The oceans will begin to evaporate in a runaway greenhouse effect, transforming our atmosphere into a suffocating, superheated blanket of steam. The tectonic plates will lock up as the lubricating water is boiled away. The surface of the Earth will become indistinguishable from the hellscape of Venus, sterilized of all biological structure, baked by a star that is simply following its mathematical life cycle. Further down the timeline, the Earth's core will slowly finish cooling, permanently shutting down the magnetic dynamo that protects our atmosphere from the devastating impact of the solar wind. What little atmosphere remains will be ionized and stripped away into the vacuum, leaving a scorched, irradiated rock orbiting an increasingly unstable star. We are not exempt from the violent history of the universe, nor are we exempt from its cold, sterile future. The environments we observe through our telescopes are not just distant alien worlds, they are previews of the inevitable mechanics that govern all matter. We are simply existing in the quiet, temporary interlude between the chaotic fire of planetary formation and the freezing silence of total entropy. And as we continue to stare into the dark, decoding the shadows of worlds that are burning, freezing, and disintegrating, we are forced to confront the immense unspoken weight of what that implies for everything we have ever known and everything we will ever build. When we finally pull our gaze away from the spectral data of these distant, hostile worlds and look back down at the soil beneath our feet, the context of human existence is fundamentally and irrevocably altered. The night sky, once a canvas for our mythologies and a comforting symbol of eternity, transforms into a vast, silent warning. It is no longer a gentle canopy. It is a sprawling, mechanical slaughterhouse operating with absolute thermodynamic indifference. To understand the exoplanets we have discovered is to finally grasp the true, terrifying scale of our own isolation. For millennia, our species has operated under a profound delusion of centrality. We constructed philosophies, religions, and entire civilizations on the bedrock assumption that the cosmos was in some way designed for us, or at the very least, waiting for us. We viewed the Earth not as a fragile anomaly, but as the standard template of reality, the natural culmination of a universe that favored the emergence of consciousness. But the data does not support our arrogance. The data explicitly refutes it. The universe is not a theater built for human drama. It is a blind, grinding engine of mass, radiation, and gravity in which the delicate chemistry of life is nothing more than a highly improbable temporary contamination. Consider the entirety of human history. Every empire that has risen and fallen, every war fought, every symphony composed, every mathematical theorem proved, and every generation that has lived and died on this planet. All of it has occurred within a microscopic fraction of geological time, on a microscopic speck of silicate rock in a quiet, undisturbed corner of a single, unremarkable galaxy. Yet, in the time it takes you to simply draw a breath, a migrating gas giant hundreds of light years away has crushed another terrestrial world into dust. In the time it takes you to sleep, a red dwarf has unleashed a magnetic flare that has permanently sterilized a planet capable of holding oceans. The forces that govern reality operate on a scale of violence and time that renders every human triumph and tragedy mathematically indistinguishable from zero. This realization forces us to confront the deepest, most unsettling silence in the cosmos. We have pointed our antennas at the stars, listening for the faint, organized electromagnetic whispers of another civilization, another consciousness reaching out from the dark. But we hear nothing, just the static of the cosmic microwave background, the rhythmic pulses of dead pulsars, and the chaotic noise of stellar combustion. This silence is not a mystery. It is an answer. The extreme architectures we have uncovered, the tidally locked infernos, the disintegrating rocks, the wandering rogue planets, are the physical mechanisms of the Great Filter. The universe does not actively hunt for life. It simply creates environments where the sustained survival of complex biology is virtually impossible. The silence we hear is the sound of 1 trillion worlds dying before they could even learn to speak. And this isolation will only become more absolute. We are currently living in a privileged epoch of observation. The light from distant galaxies still reaches us, allowing us to map the structure of the cosmos. But the fabric of space-time itself is expanding, driven by the relentless, invisible force of dark energy. The space between the galaxies is stretching at an accelerating rate. Eventually, this expansion will exceed the speed of light. When that happens, the light from distant galaxies will no longer be able to bridge the widening gap. They will simply fade from view, crossing an event horizon of cosmic isolation. If humanity, or whatever we might evolve into, manages to survive deep into the future, our descendants will look up at a sky entirely devoid of other galaxies. They will see nothing but the fading stars of our own local group, surrounded by an infinite, impenetrable blackness. They will have no physical evidence that the rest of the universe ever existed. The grand violent machinery we observe today will be completely erased from the visible record. They will be entirely alone in an ocean of nothing, unable to know that they are the last lingering ghosts in a dying universe. Ultimately, the inexorable march of entropy guarantees the end of all structure. The last stars will exhaust their fuel and fade into dark, degenerate spheres. The galaxies will dissolve, their dead remnants either swallowed by supermassive black holes or flung outward into the freezing void. Even the black holes themselves, given enough trillions of years, will slowly evaporate through Hawking radiation, bleeding their mass away as faint subatomic whispers until there is absolutely nothing left. No light, no heat, no gravity, no matter. Just a uniform, infinite, completely dead vacuum, resting at absolute zero. A cosmos that has finally achieved perfect eternal equilibrium. This is the ultimate, inescapable destination of the chaotic machinery we observe. The burning giants, the frozen oceans of black ice, the diamond mantles, and our own quiet blue world are nothing but brief, insignificant sparks in a long, dark corridor leading toward the final, absolute silence. We are born in the shadow of this engine. We exist by sheer mathematical chance, and we will inevitably be swallowed by the same indifferent physics that forged us. There is no grand design, no final purpose, and no escape from the cold, terminal mechanics of the void.